We now introduce a function that's called the absolute function, and it's just a way of expressing how far away a point is from 0. So if we've got y equals the absolute value of x, and that's how we write it, just with straight lines on either side of the x, it just says how far away we are from the origin or from 0. So it has no negative. So we don't get, whenever we've got absolute value, the least value we can get is 0, and then all the other values are positive. So it's just how far away it is, a length, and a length can't be negative. So here we've got y equals the absolute value of x. To get an idea of what it looks like, if we simply just plot y equals x, as you know from previous work, it's a linear function and makes an angle around about exactly 45 degrees with the x-axis if the scales on the x and y are exactly the same. So that's y equals x. And to get y equals the absolute value of x, we just reflect this part here where y is negative, and as we said, y can't be anything less than 0, so there is going to be my least value for absolute value. And so we reflect this value, or these values here, in the x-axis, and it comes up there at 45 degrees. So maybe just do that over the top in red to show that y equals the absolute value of x. So for instance, if you had y equals the absolute value of 4 minus 6, we would calculate that inside first. 4 minus 6 is negative 2, and the absolute value of negative 2, how far is negative 2 from the origin? And that would be 2 units. Y equals the absolute value of 0 is 0 as well. So that's y equals the absolute value. Just to do a simple one, so if we go y equals the absolute value of x plus 3, and we've already looked at transformations. So if we graph y equals the absolute value of x first, we do this part first, and that's our y equals the absolute value of x. And then what effect does this 3 have? It simply moves y equals the absolute value of x 3 units. So this line coming down here is going to be parallel. Once again, I'll do it in another colour. So we go down here. So it'll be parallel to that one, 3 units up. And this one will be parallel to that one there. So this is y equals the absolute value of x plus 3. And the original one here obviously was y equals the absolute value of x. Alright, so there's nothing more than that to it. Graphing these functions, we can get into something a little bit more complicated here. So we've got y equals the absolute value of x minus 2 plus 3. It's a good idea to do these in steps, and we can start with, well, let's start with a good Cartesian plane xy. And we can start with y equals the absolute value of x. So that's y equals. All right, now we've got to look at what effect the minus 2 has and the plus 3 has. So we've got to see what those two do. Let's look at this one first. When we've got the minus 2 here inside the absolute, if it is negative, it's going to move it to the right that many units. So this is a horizontal shift. Negative to the right, positive there would move it 2 units to the left, but we've got a negative 2 there, so it's going to go across 2. And if we drew that one, let's do that one in red. And once again, this is going to be parallel to that one there. And going out this side will be parallel to that one there. So that's y equals the absolute value of x minus 2. As I said before, if it was absolute value of x plus 2 inside the brackets there, plus 2 would move it 2 units. If it was 3, it'd be 3 units, and so on. Okay, so we've done the minus 2. Now we've got to do what effect the plus 3 does. Now the plus 3, as we've seen before with work with linear functions, y equals x plus 3. Plus 3 just moves it 3 units vertically, so this is a vertical shift. I'll maybe do that in another colour, eh? This is a vertical shift. So we're going to go 1, 2, 3 units up. So this point here, this where it turns around, is going to go 3 units up to there. Once again, it's going to be straight up from the red line here, so that's going to go up there, and that's going to go up there. So that's y equals the absolute value of x minus 2, and then we have used it 3 units. We've moved it 3 units vertically. Okay, the last one, let's just do that, is y equals minus absolute value of x plus 1 minus 2. Okay, we'll do it in stages again. So we'll draw our xy plane. And y equals the absolute value of x plus 1. So we know that y equals x looks like that. Absolute value of x plus 1 will move it 1 unit to the right. So we'll do all of these in different colours. So that's y equals absolute value of x plus 1. So 1 unit across, so that would have a point of negative 1 there. What does this negative do? The negative actually just reflects whatever you've done there in the x-axis. So it flips it, if you like. So what we're going to get is a graph. So this line here will be reflected like a mirror, and it'll come down like that. So whatever the line there is reflected to that one, and this blue line going up there is reflected in the x-axis. So it'll come down like that. So that is y equals negative absolute value of x plus 1. So the negative out the front just flips it. And then minus 2 simply moves it 2 units down. So if we go minus 1, minus 2, I'll put it over here to give me a bit of room. So that's minus 2. So this point here, this turning point, is going to move down to that point there. So that's what this minus 2. This is my vertical shift, and when it is negative, it moves it down. So we'll get one more colour going here, something that you can see. So we'll go a red. And this is y equals negative absolute value of x plus 1 minus 2. Okay, so it's good to show all the different transformations, the steps. So we started here with y equals the absolute value of x. Then we've done the horizontal shift. It's plus 1, so we go to the left 1, and we end up from 0 back to negative 1. The negative out the front flips the blue one upside down into the purple one here, and then the minus 2 moves the whole graph down 2 units.